Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space guy, your cosmic bro. And we just had a big anomalous earthquake with a magnitude 6.6 on a spreading center. So just right from the get-go, that is a big earthquake. But because it is a 6.6, well, that is quite significant. So we see that right here with Google Earth, the location of this. And this is in the southeast Pacific Rise. So this is where the Pacific Plate is spreading very, very quickly at rates of greater than 10 kilometers per second, 12, 14, 14.5, centimeters per year, not kilometers per second. Centimeters per year. So this is a very, very fast spreading center geologically. And you'll notice they actually look like suture zones. Find this interesting. These are large transform faults. And then you have these spreading centers in between where you get the actual crust spreading apart and new oceanic crust is being created. So there was also a magnitude 5.0 aftershock. This is coming just a few days after a magnitude 6.7 earthquake in Japan. That was on the 15th of May. So two pretty closely spaced together, back-to-back, mid to high magnitude 6 earthquakes, a 6.7 Japan, and then a 6.6 on a mid-ocean ridge. Just earlier today, we had a 5.9 in the Ryukyu Trench for Japan and a 6.2 down here in Indonesia on the 16th. We also see that what some are saying, I think this is probably accurate, the largest volcanic eruption of 2026 is currently ongoing with the newly named Teton volcano in the central Bismarck Sea, which is around Papua New Guinea. So that's before what it was called the Central Bismarck Sea Volcano. It's been renamed to the Teton volcano. This is a local pronunciation, and it has a depth of, there's some ambiguity as to the depth of this underwater volcano. The bathymetry data shows it's like negative 1,300 meters below the surface. That's highest elevation. Others are saying it's not that deep down, just a few hundred meters below the surface. Regardless, to be erupting so profusely with so much water pressure bearing on top of it, and to be able to launch a steam column up like 10,000 meters into the atmosphere is very significant. So, or not 10,000 meters, sorry, about 10,000 feet or 3,000 meters. So this is really a big volcanic eruption that's happening, and now we're seeing more activity in the Pacific with this mid-ocean ridge earthquake. This was a oblique slip event, so mostly transform, but a little bit of extensional movement as well, really showing that Earth is expanding here. And we have this expansion and also this contraction. If we look at Earth as a whole, plate tectonics, you get contraction in the subduction zones where the plates are sliding on top and underneath each other. And then you get extension in these mid-ocean ridges. For example, the Atlantic has a very well-defined mid-ocean ridge. You see that right here. And so the plate is splitting apart like this. And you have these transform faults that kind of connect it together. See right there, that's a very clear transform fault. Here's where it's spreading. Well, we also have that in the Pacific. And here you see that the scars are really big. So very significant. If we take here, for example, let's get a topographic cross section. And so we can simply just measure right here with our measure tool, and we will see this incredible, I'll turn myself off, we'll see this incredible change in the topography going from negative 3,700 meters all the way down to like negative 5,800, going all the way then up to negative 750 meters. So that's the Southeast Pacific Rise. That ridge there is a rise, but it also has this huge trench there. This is a very important area geologically. Now we just had a big magnitude 6.6 with a 5.0 aftershock. Also interesting to this is that the antipode for this location is in Eurasia, specifically right around, like, it's in Russia, like Moscow, that area. And that is right now where we're having a pretty significant weather anomaly with anomalously high temperatures. So just interesting that the antipodal location A is having huge temperature increases over normal right now for this time of year, etc. But B, also an area that's very seismically quiet. You basically don't have any big earthquakes on record in that part of the interior of the continental plate for Eurasia. And you're less likely to get big earthquakes in the continental interior, but we see that where the Earth is in some aspects its most solid, this big craton, this continental craton of thick lithosphere, continental crust is very solid and rigid. You have at the other side an area on the planet where the crust in some aspects is the thinnest, the weakest, and it's actively ripping apart. So you see this duality that's mirrored across the Earth, which is very, very interesting. So this is normal in the grand scheme of things, but in general, you don't see a magnitude 6.6 earthquake. In general, you don't see a magnitude 6.5 earthquake or greater on a mid-ocean ridge. That is quite rare, but we do see them, and well, we're seeing one today. So just a lot to cover in today's video. I've been busy with this event that we held in San Diego. I'm also getting over just having been sick, so just FYI, if I cough or sneeze, I'll do my best not to, but it has been happening. And I'm just going to catch you up on kind of some of the things that have been happening over the past few days, because we've had quite a few things. We see this magnitude 6 here that struck in the Caribbean. This was on the 16th of May. We've also had a flurry of close asteroid passes around the Earth during this time frame. So here we have our USGS latest earthquakes map, and we can see that this 6.6 and the magnitude 5 are the most recent earthquakes to occur. And if we go to our highest magnitude quakes, we see it's the 6.7 and the 6.6 are our biggest. And so you notice that the activity is really clustered here in the Pacific, and it has been. So we had Kilauea go off with episode 47 there on the 14th of May, finishing right as the day turned to the 15th Universal Time. Then just about 12 hours later, we had the 6.7 that hit Japan. We also had the 6.2 that struck as Kilauea was erupting here. That was on the 14th of May. We had the follow-up 5.9, originally came in as a 6, 5.9 there, Japan. You also notice that we've had 2 magnitude 5 earthquakes here in China, which has kind of been interesting. We see them right there because there has been some antipodal action with that. Those are quite destructive, even though they're only magnitude 5s, because the building quality, I guess, is not good in that part of China. That's what we've seen. Some video came out. But this is roughly near the antipode. Here we see a 5.8. So interesting that the antipode for China is this strong subduction area right there. And that 5.8 probably being an antipodal sequence occurring, you see there on the 19th, after those magnitude 5s hit. And let me show you the fault solution for this. So the depth at 23.5 kilometers, that's what they've calculated. And if we look at our moment tensor plot, you see here P is where the compression is, T is where there is tension. And so you see that overall it has been pulling apart. This is a sign that it's been pulling apart along this vector, right? Like, oh God, this is difficult. Along this vector right there, okay, where it's been compressing along this vector here. So again, it's been extending along that vector, compressing along that vector, but it's mostly strike slip. So most of it was just plates grinding past each other. But what we specifically see, if we go back to Google Earth, is if we go here, we specifically see in the Southeast Pacific Rise, right there is where we get this bend. So you have this transform fault that then bends into a mid-ocean ridge, and it's specifically in these locations that it's not uncommon to see a an event like this where it's mostly strike slip, but a little bit of dip as well due to normal faulting and extension. So that's pretty interesting. And you know strike slip when you get this perfectly centered and you have these cross lines right in the center of this volleyball. By the way, if you've ever been researching into these moment tensor plots by the USGS, it's all kinds of makes no sense because normally the shaded region is the compressional zone and the white region is the tensional zone. Instead, they flipped it so the shaded region is tensional and the compressional region is P, and then normally the compression is a C icon and not a P icon. And so you're reading this, you're like, what the F does this mean? And they don't give you a legend or an explanation. They have no explanation of what this thing is. So you really have to go out of your way to be able to understand these, which is, I don't know why they do this. It's a little, I'm getting off on something here, but you want people to understand what these products are that you put out. And when you purposely flip the color legend and you don't provide an explanation for that, I think you're doing a lot more damage than good. Because people like probably misinterpreting these. It's just crazy. So just wanted to point that out for you. Let's look at our, if you're trying to read these yourself, let's look at our antipode map. Here we see the location. I just typed in Moscow here, and you see it's roughly the location of this earthquake. See the exact antipode is roughly in between New Zealand and the southern tip of South America there, as you can see with this map. And if we go here back to Google Earth and zoom out, you see that's roughly where we are as well here. We have southern tip of South America and we have New Zealand, and it's roughly in that location. So the antipode is roughly Moscow. And just kind of looking around, I'm not saying that they're connected other than just through this relationship, but you do see that one of our biggest climate anomalies right now is directly over Eastern Europe and Moscow with that antipode. So interesting that we see this huge climate anomaly there. And it was worse just a few days before. And there are these connections between the temperature of the atmosphere and angular momentum of the planet, and therefore spin rates and earthquakes. And you can really talk about that on longer time scales, especially as it relates to changes in orbital periodicities and more. But I just find it kind of an interesting coincidence. So, and if we finish up that train of thought, here we see our USGS earthquakes map for magnitude 5 or greater earthquakes for this box I drew around this part of Europe, going all the way back to the year 1800. And we see a bunch of nuclear explosions. That's what these diamonds are. But you don't really see that many big magnitude 5 quakes. In fact, you almost see none. You see a bunch here in Europe, of course. I drew that box and it did get that. But if you look right here, there have been no recorded magnitude 5 quakes anywhere around Moscow since the year 1800. Like anywhere in this location. Super, super odd. And that is where the antipode for this magnitude 6.6 is. Again, where Earth's crust is in some aspects the weakest with all this rifting and tension and faulting and more, where you have some of the thickest continental crust on the planet, it's the exact opposite, and you don't have any earthquakes there. Here we see our global seismic activity level, and you can see this periodicity we have right here with coronal holes on the sun. So every single peak there with earthquake activity is linked up to this coronal hole that we can, well, we won't see it on this imagery I'm about to show you right now. Here we have our imagery of the sun, but there's a large coronal hole that we just had go through when we're entering into those high-speed streams. For quite a long time now, all the biggest earthquakes have been linked up with that. So we are not right now under the influence of a coronal hole, but we are just coming off of that. It just happened. So we are seeing this periodicity pretty nicely line up with that going like this, but slightly outside of the normal zone. That 6.7 was smack on. So now this 6.6 really bringing to awareness what's happening in the Southeast Pacific. And just in general, if we go back here, we see all the activities clustered in the Pacific Ocean and just around the Pacific. 6.2 Indonesia, largest volcanic eruption of 2026, may even be the largest of 2025. The 5.9 Japan, the 6.7 Japan, right? It's all in the Pacific. Kilauea, episode 47 on the 14th, and we're about to have the next eruptive episode in just a few days. So probably this week, we see our inflation right here getting close to that level that we've been kind of having these eruptive episodes at recently. Here we see our 3-month data. So we've been having these shorter, faster eruptions, and we're getting close to that right now. So one thing I'll mention before I go into just kind of the forecasts, in the thumbnail, title, etc., I said earthquake and volcanic activity, like a big wave of it is coming. What do I mean? I'm talking about how there is an increase in earthquake activity and an increase in volcanic activity that is statistically significant for solar cycles. And this is that we have more volcanic activity and more earthquakes, specifically high magnitude earthquakes, that's key, during solar minimums versus solar maximum. During solar maximum, you have all this energy loaded into the earth, and then it seems that when you have the sun start to quiet down, that energy then rebounds and we get this big burst of activity with earthquakes and volcanoes during solar minimum. It is statistically significant. It's not that big of an effect, but it is, again, statistically significant. So that means that if we're seeing a lot of activity right now, at least this, you could speculate this, we're seeing a lot of activity right now. Kilauea, Titan, or Teton volcano, right? We may be seeing a lot of activity in just a few years. Now, this isn't end of the world activity. These are natural geologic changes, but they can have real world human effects, as we've seen time and time again. And that's important to be aware of because, well, personally, I value human life and I want people to live happy, healthy lives in relative safety, without having to fear about outrunning a pyroclastic flow. Let's just say that. So the interesting thing that occurred, if we go back here, is that this occurred with a synchronicity for me. So just to quickly tell the story, because it just happened today, just a couple hours ago, is I was reading this research paper here. Maybe it's a little difficult to read. It's linked in the video description. It's from 2015. It's mid-ocean ridge eruptions as a climate valve, okay? And they specifically talk about the Southeast Pacific rise in this paper, because they're looking at how mid-ocean ridge eruptions release CO2 and seem to have a periodicity that lines up with the 100,000 year orbital Milankovitch periodicity too, and that's also climate periodicity. So we see this large-scale modulation of volcanic activity at Earth's plate tectonic spreading centers based off of orbital factors, climate factors, and more. They talk about it and everything. And so right as I'm reading this paragraph on the Southeast Pacific rise, we get this magnitude 6.6, which is anomalous on the Southeast Pacific rise. So it really feels like Earth saying, hey, you should really pay attention to this, okay? So I am. But that's the synchronicity. Pretty crazy, because again, this does not happen every day. To get a magnitude 6.5 or stronger earthquake on a mid-ocean ridge is like maybe once a year, if that. So it's pretty crazy, the synchronicity there, in my opinion. So I think we have more activity coming in as we go into 2028, 2029, 2030, 2031, 2032, which is when we will have our next solar minimum. If we go to solar activity here, and we look at our solar cycle progression, we can see where we are right now in solar cycle 25. You can kind of zoom this in a bit too for you guys. And actually, let's go out even further. Let's go all the way back, actually. Let's do this. I'm going to turn myself off. We see solar cycles going back to like 1880. Okay, so this is solar cycles 12 to 25. And you see this modulation where about every 80 something years, 85 years or so, 88 to 100 years, you have this reduction in solar activity. It's called a Gleisberg cycle. If I really expand this out, you see right here, this Dalton minimum around the year 1800. You see that in the year 1900, around this time frame, we also had a lower solar activity. Then you see 24 and 25 have been weaker. Now 25 has been stronger than 24, but you see in general this about 88 to 100 year periodicity right there, right? Well, the interesting thing is that not only is the 11-year solar cycle visible in volcanic data, like very clearly, statistically significant, like 97% confidence, we also see that 88-year cycle or Gleisberg cycle show up in volcanic data. And that one has a lot of supportive evidence for that. And if you read these two papers, then you'll get a sense of that because they talk about these cycles. So we are right now in this period where we can expect heightened activity because we are at the bottom of a Gleisberg cycle. And that's another one of these waves that in general brings in bigger volcanic eruptions. And well, case in point, let's zoom in here this time. Let's go like here, I guess. Case in point is that we had Hunga Tonga Hunga Apai in 2022, right around here. That was January 15th, 2022, during the early ascending phase of solar cycle 25, after that solar minimum. We're having Teton volcano erupt right now, and we could get something bigger. But Hunga Tonga Hunga Apai was the biggest eruption so far in the 21st century, and going back quite a way. So we've had some big volcanic activity, and since these are longer time cycles, they don't have to necessarily happen exactly at the absolute like minimum of that Gleisberg cycle. There's a bit of variation, 88 to 100 years. So we could be looking at bigger activity coming forward. And the fact that we're seeing big activity right now here, just after solar maximum, it's like, what are we going to be seeing in this 2030 to 2032 range? That's going to be really interesting. It could get quite significant. Another thing too, if we really kind of look at the record, is that we also do see this connection though between bigger solar cycles and bigger events in the corresponding low period afterwards. So here you have solar cycle 19, strongest since solar cycle 3 in the late 1700s, right? Huge amount of sunspots, tons of flares, things of this nature. Well, we had the magnitude 9.5 in 1960. Now that's right here at the end of maximum, beginning of the descending phase. We had that in 1960, and then in 64, we had the magnitude 9.2 strike Alaska. So while they didn't necessarily cluster during the solar maximum, it was more in this zone right here, right? They came after a really strong solar cycle. They also came after we were exploding nuclear bombs everywhere on the planet. And what does a nuclear bomb do? It creates a whole bunch of plasma, and once you create plasma, it can zip and zap around anywhere. Because plasma could shoot down and go straight into the crust. It could go out to space, right? It's not confined like ordinary matter. It's just a bunch of charged particles, and it can move through solid objects because, well, in reality, at the plasma level, it's not solid anymore, right? These are charge carriers. So that's also interesting. We have this corresponding huge increase in nuclear testing corresponding with a big solar cycle and also big earthquake activity. Something to keep in mind. But we are right now at the end of a Gleisberg cycle, and that is seemingly having an influence over volcanic activity because we've already had a big volcanic eruption with Hunga Tonga, and we could have a big eruption at Teton. Like it very well could continue to escalate into an even bigger volcanic eruption. It's been erupting since May 8th, and it's going to probably keep erupting for a while. It's very active. It's only had one historic eruption that we know of, 1972. So we're very likely going into more activity. The interesting thing also to note about this 88 to 100 year periodicity is that that's roughly the orbital resonance with Uranus and Neptune. So there's a lot of ideas that the influence in, the 11-year roughly solar cycle, it actually ranges from like 8 to 17 years. Jupiter has a 12-year orbit around the sun. So they're very closely aligned. We see very strong spectral peaks at around the 11-year solar cycle with earthquakes, volcanism, Jupiter's orbital periodicity. We see the same with, the orbital periodicity of Uranus is 84 years, Neptune's 164. So combined, they kind of create that Gleisberg cycle. Now, one thing to keep in mind, this is interesting as well, is that we see right now we have this basket forming. Now, maybe you've heard of this from some astrologers, but you notice that we have these trines, sextiles, and this opposition that are active between the outer planets. So we have Pluto here. This is true sky, constellations, accurate to size. Okay, so it's not your Western tropical astrology chart. This is a true sky astronomical chart. We have Pluto there in Capricorn. It's sextile to Uranus. We have Neptune and Saturn there, sextile to Jupiter. We have Jupiter in opposition to Pluto, and we have sextiles in between them. So we have, again, Saturn, Neptune in trine. That's what I meant to say. In trine to Jupiter. We have Uranus in trine to Pluto, sextiles in between, and then opposition between Jupiter and Pluto. This is going to go exact in the summer, okay? Right now we actually see, because the moon is passing over Jupiter, that the moon is completing this configuration. This special geometry in the sky is being activated every 28 days or so by the moon. We see as the moon continues there, it forms all these patterns, and if we go forward, right, then it activates them. If you move it forward here, now we start to see that Jupiter, and there's a bug here with these popping to the other side. We see this opposition there start to form in June with Jupiter, with the planet furthest out, which is Pluto, and then we get the moon to sweep through like this. See that? So now we get this basket. It's really interesting. So I think this is also having an influence on this, because we just saw how the Gleisberg cycle and Uranus-Neptune orbital resonances are connected together in terms of the periodicity and how that's connected to solar activity and volcanism. Read these papers to learn more. They're linked in the video description. And now we see that they're all forming a geometric pattern in the sky that the moon then also further reinforces with its normal 28-day rotation, its orbital journey. So really interesting stuff. That is what I wanted to present to you. Just a last closing thought, as I've covered in some other videos. We've had some, pretty significant bursts of close asteroid flybys going back to about May 7th, which is interesting. And we see that on the 18th, which was a key date that was identified because of 2026 JH2 there being 20 meters across, coming at 0.2 lunar distances, that two other asteroids were also picked up on the 18th, coming in at less than 1 lunar distance. Now, not as big, but still 3 all at the same time in one day doing close flybys of the Earth. If you look forward, we don't see anything really significant on the horizon, but we've been in this surge of close asteroid flybys at this time frame. So that's important to know, just in terms of our space weather context, I guess you could say. Now, another thing too that's been happening is we can look at our sun. This is our 211x view with our 193 filter, and we don't see any big coronal holes. We do see more activity coming in with these sunspots. So we will have some pretty big sunspots on the Earth-facing side of the sun in just a few days. If we look at our far side view, we see that here is this very large sunspot that formed. Interesting story here, also showing you the connection between solar activity and planets, is that on the 13th through 15th of May is when we had the superior conjunction of Mercury as viewed from Earth, which means that it is an Earth, Sun, Mercury alignment. Now, 180 degrees is going to be exactly opposite the Earth, right? Because Earth is going to be at 0. This is taken by a solar orbiter probe located at a slight angle away from that perfect 180 because Earth is right there. Solar orbiter is there, slightly there. Well, if you look at the date here, you'll notice that this sunspot group was turned into a mega sunspot group, formed like instantaneously as it rotated to face Mercury at that 180 degrees. And we also see that this sunspot group just above it and to the right also experienced a surge of flux. And now this mega sunspot has decayed quite rapidly on the far side. So we will get some activity to rotate into view in just a few days. But this sunspot was, as you can see, clearly at its greatest extent right when it was facing Mercury. This is during a superior conjunction of Mercury with the two planets that have magnetic fields in the inner solar system, Mercury and Earth. The other two planets, Mars and Venus, they don't have that. So that's important. And another interesting thing to point out is that we can look at the planetary energy via total solar irradiance for the planets. And we see that if you take total solar irradiance for a planet, its location, orbit, you know, the energy that's being emitted from the sun decays via inverse square law. So if you double the distance, decreases by 4, you triple the distance, goes down by 9, that type of deal. And then you take the cross-sectional area of a planet, because these rays are coming in effectively perpendicular to the planet. You don't count it over an actual half sphere, you count it over a circle, because that's the incident plane that they're coming in on. They're not scattering at different angles. So you take that cross-sectional area of the planet, and then you can calculate as a result the total intercepted power from the sun for these planets. And very interesting things emerge when you do this. So we see here that Mercury, right there, and Earth have nearly the same total intercepted power. And why? So, well, Mercury is closer, but it's a smaller planet, so its cross-sectional area is quite a bit less than the Earth. See, that's about order of magnitude different. Mercury is at 1.87 times 10 to the 13 meters squared, right? Earth is at 1.28 times 10 to the 14. But their total intercepted power is the same at around 170 pentawatts. A lot of energy. You'll also notice that we have other planets right there in this zone. Saturn, being a much bigger planet but further away than the Earth, has a total intercepted power of 160 pentawatts. So on a planetary scale, these planets are receiving the same amount of energy if you account for their size, which is interesting. You would think that, you know, the bigger planets are receiving more energy, and well, in Jupiter's case, they are. Jupiter here receiving 775 pentawatts because it's so much bigger, even though its total solar radiance is receiving is quite a bit less than, let's say, Earth. You know, it's only 50.5. Jupiter's so big that it actually brings in more overall because of its cross-sectional area. It is the planet receiving the most amount of energy from the sun. But you do see that Mercury, Earth, and Saturn there are very similar in their pentawatt rating, you could call it. And then Uranus and Neptune are quite a bit further down. And we see Venus, which is interesting, right there, actually receiving overall more energy than the Earth does. So the Earth is a very active, dynamic place, has a magnetic field, has a global electric circuit, all this stuff. Venus is actually receiving not double, but close to double the energy from the sun on an absolute scale that Earth is, because it's closer and has about the same radius. So that's very interesting. So from that context, the fact that we had the same planets, which is Mercury and the Earth, in this alignment, right? And then right as that happened, you get this mega sunspot to form. It's clearly showing some ability to influence the solar dynamo, or at least solar flux, you know, electromagnetic flux on the surface of the sun. I think it's kind of a case closed scenario. And we were, really adding case closed says that we were forecasting this. When you're able to make a forecast, like, you know, basically a prediction, saying we think that this is going to happen, and then it does, you probably have something to it, especially if you can repeat that over time. And, well, you guys know that we've done this many times. We've had some misses. We've had a lot more hits than misses with this stuff. So This is showing an example of how the planets are able to influence the sun. So clearly we're seeing the larger picture of the planets, the sun, the earth, how everything is connected together. We see this clustering of activity for volcanic events when the earth tides are stronger on the planet, which would be around the perihelion of the earth in January. And then as you pull further back from that, that reduces. Case in point, Hunga Tonga, Hunga Abhai, January 15th, right? Our perihelion, our closest to the sun, where the solar tide is the strongest, is the 2nd of January. So just shortly after that perihelion, we had that big event. And the connection proposed is that these solar tides, they can create rock fractures, and then that can actually, these earthquakes, for example, these fractures can either A, weaken the crust, but if it's in a certain state, it actually creates more room for magma. So you have stronger tides, which could pop the zit, you could say. But if it's set up a certain way, it can actually create larger magma chambers, for example. If you go to our latest earthquakes again, let's check this out. Let's switch this to 30 days, all magnitudes. Let's look at the Bahala earthquake swarm, because I just want to show you, we've been talking about activity in Hawaii. We have 47 episodes now, Kilauea. We see some earthquakes there. But we have here Pahala, this earthquake swarm. And this really started up in 2019. And basically, there's been a ton of micro earthquakes expanding these horizontal sills that exist underneath the surface of Hawaii, 35, 45 kilometers down. And so if that wasn't happening, you still are continuously having magma and pressure come up from deeper. You'd expect there to be some big events to occur because, well, if it's not going to go into new fracture zones and fill it up, well, you're going to get it to come to the surface. We've been seeing the volcanic activity in Hawaii actually shorten and shorten, these smaller events, kind of premature events. Well, what this means is that as we go into solar minimum, we should expect there to be more activity. And now that we've had more fracturing of this zone that connects Kilauea to Mauna Loa here, when it does come time for an earthquake and we do get that pressure wave to hit, you now in general have more magma here than you did before. So you could have a bigger event now because there's simply a larger reservoir. So this is what I'm talking about. As we go forward, this earthquake, this volcanic wave that's coming, we could be quite surprised by the size and ferocity of some of these events. Does not mean it's guaranteed to happen. There is a lot of randomness, but we do see some trends, especially when we examine them for certain periodicities, which are basically observed everywhere, which is that solar periodicity of 11 years or that Gleisberg periodicity of about 80 to 88 years. So right now everything is fine. Thankfully, this magnitude 6.6, it occurred in an area where there's no tsunami risk from this. We did have a magnitude 5 aftershock. It's a big event, but it's nothing catastrophic. We haven't had something catastrophic for quite some time, thankfully. That we do have this big volcanic eruption here. It's, at the end of the day, not really affecting anybody, but it could. If you get some slope collapse, you could get a big tidal wave to go across, tsunami wave. There's a lot of potential for these sort of things, but right now everything's fine. But these are all signs of where the Earth is right now and perhaps where she may be going. Because again, as we see the fact that we are experiencing some high activity, we did have the magnitude 8.8 megaquake during solar maximum, July 2025, right? The peak for solar maximum, the absolute peak, was August of 2024, but it was going from 24 to 25, for sure. Really is more like mid 23 to 26. Maybe we get some really big stuff to occur during solar minimum. So That is your update for today. I've been your host, Stefan Burns. Thank you all so much for watching. If you like the video, please smash that thumbs up button to help this channel grow. Subscribe to stay up to date on everything that's happening with the Earth energetically, earthquakes, volcanoes, solar activity, space weather, planetary alignments and resonances, interstellar and cosmic forces, consciousness, and more. Wishing each and every single one of you a great day. Please take care of yourselves. I'll see you all in the next video.